This is our fifth video for Chapter 7. This is Chapter 7, Section 5, Functions in the Real World. What you'll learn in this video is to use equations, tables, and graphs to represent real-world functions. Give me just a second because I just noticed my typo. What you'll learn. There we go. Remember, an expression is a mathematical phrase that contains numbers and operational symbols. Now, tables, graphs, and equations can represent functions. So tables, graphs, and equations can all represent functions. You can make a table, graph, or equation to represent a situation that can be modeled with a function, such as hours worked and money earned. You can then use the representation to solve the problem. So as we've done in previous sections where we're just given a table and we have to find the pattern, or given a function and we have to figure out what the table should be, this will be primarily word problems figuring out how to make the tables and the graphs give us the information we need. Let's look at an example of using a table. Paul works in a pet store during the summer. He earns $7.50 per hour. We want to make a table showing the relationship between hours worked and amount earned. So how much does he earn in a week if he works 22 hours? First, we need to determine the independent and the dependent variables. The amount he earns depends on the number of hours he works. So dollars is the dependent variable and hours is the independent variable. Then we're going to make a table of the possible amounts that he earns. Choose some values for the number of hours worked, including 22 hours, then find the amount he earned for each value. To do this, multiply the number of hours by 7.50. Then we would just need to answer the question once we had filled out our table. When Paul works 22 hours, he earns $165. So 7.5 times 22. Pause the video and do the quick check in your notebook. Be sure to make a table showing the relationship between hours worked and amount earned. Let's look at another example, this one using a graph. Say a car travels at 30 miles per hour. How far does a car travel in 5 hours? So again, we need to, step one is determine the independent and the dependent variables. The distance the car travels depends on the time of travel. So miles is the dependent variable and hours is the independent variable. Then we're going to make a graph of the situation. So in 0 hours, the car obviously goes 0 miles, so 0, 0. Then in 1 hour, the car goes 30 miles, so 130. So in 2 hours, the car will go 60 miles, so 260. So we would make our line and then just follow the line until we find where it hits 5, 5. So at 5, it hits 150. So in 5 hours, the car travels 150 miles. Pause the video and do this quick check in your notebook. Be sure to show all your work. Let's look at an example of using an equation. Say we're buying tickets. Tickets to the concert cost $10.50 each. Write an equation showing the relationship between tickets purchased and the cost. So how much does it cost to buy 5 tickets? So step one, again, we're going to determine the independent and the dependent variables. The cost depends on the tickets purchased. So cost is the dependent variable and the number of tickets is the independent variable. Then we're going to write an equation. The independent variable is the number of tickets purchased, and the dependent variable is the cost. So cost equals 5 times the number of tickets purchased, or the cost of tickets purchased rather. So we substitute 10.5 for x and simplify. So y equals 5 times 10.50, which equals 52.50. So 5 tickets cost $52.50. Pause the video and do this quick check in your notebook. Be sure to show all your work. Now it's time to check your understanding. Be sure to label it as check your understanding in your notes, number all the questions, and show all your work. Enjoy the rest of your evening, and I'll see you tomorrow.